Welcome. Let's look at absolute value equations. The basic thing about it is that if you have an absolute value problem, A equals B, you're going to have two cases where you're going to have A equals B and A equals negative B. Or it can be done, and has been done there, where you could, instead of that, you can do A equals B and negative A equals B. It actually comes out to the exact same thing. It really doesn't matter which way you do it. Right, but I prefer this one, so that's the one I'm going to show. So in this first problem, we're going to have x plus 15. Oh, and I'm going to call it case A and then case B. That's probably the single biggest thing people have to remember about this is they forget to do two cases. X plus 15 is equal to 12 and x plus 15 is equal to negative 12. So now let's do the subtract 15. X is equal to negative 3. Subtract 15 and x is equal to negative 27. So the solution set is that x is equal to negative 27 and negative 3. So unless you're told to, you don't have to put it in set notation like that, but it certainly doesn't hurt either. And the x equals can be on the outside instead of the inside. But still, this shows that the set of answers is the negative 27 and negative 3. Now, the next problem shows the second place where people make mistakes. So the first place people tend to make mistakes is forgetting two cases. In fact, I'll write that here. Errors. Forgetting two cases. And the second thing is not cleaning it up. So those two things. And this next one is the cleaning it up. Notice that back here, when we had this absolute value, we could then do the two cases. It has to be the absolute value only on one side, only. And on this next problem, we have two other things over here outside of the absolute value. You have to get rid of them first. You cannot do the two cases until you get rid of them first. So we do the opposite of order operations when we're undoing a side. So I'll add the 20. And so I get 3 times the absolute value of x plus 2. 20 take away 8 is 12. By the way, just as a little side, do not ever try to do that. It's not a distributive property. Absolute value bars are not distributive property unless you are removing the absolute value bars and then working with it. But in this case, if you know what x is, you plug it in there, apply the absolute value, and then you multiply by the 3. But we don't know what the x is yet. So back to here now. We now are going to divide by the 3. So we get the absolute value of x plus 2 is equal to 4. And now we can do x plus 2, absolute value of x plus 2 is equal to 4. Now we can do the two cases. Okay, so having done that, we'll do x plus 2 is equal to 4. X plus 2 is equal to negative 4. So subtract 2 here and subtract 2 here. So x is equal to, looks like a negative 6. And 4 take away 2 is 2. Okay. Whenever you're not sure, put them back into the problem and see if those numbers work. So if I put 2 in here, I get 4 times 3 is 12, take away 20, negative 8. And back here, if I put negative 6 in, I get negative 4. The absolute value makes it 4 times 3 minus 20. It works. So both of those answers are correct. So 2 answers for it. Almost always 2 answers. So always do that. Okay, now here are a couple more of them. Try these out yourself. Stop the video for a moment, do them, and then come back to the video. I will start in 3 seconds because that, for you, that could be 15 minutes. All right, here I am. Let's do the cleaning up and 15. 5, 2x plus 3. 60 plus 15 is 75. I'm going to divide. 75 divided by 5 is 15. Okay, 50, yep, 75. Now I'll do the two cases. 2x plus 3 is equal to 15. And notice I don't use the absolute value bars when I do the two cases, either one of them, because the purpose of it is to split it into two like this. All right, so I'm going to subtract the 3. I'll subtract it here too, so I get 2x equals 12. And here I get 2x equals, what's that, negative 18. Okay, so we get x is equal to negative 9 and 6. And if you put that back in, you'll find that both of those will work. And now on the next one, I'm going to subtract the 50, subtract the 50. So I get absolute value of x plus 3 is equal to negative 40. Stop. The absolute value, whatever I put into x, it's going to become a positive number. There is no way that I can ever get a positive number from this that will be equal to negative 40. That negative is sort of like a trick question. I agree it is, but it's to see that you're aware that absolute value numbers are like a distance from one place to another. It must be a positive. So the x itself could be a negative, but the absolute value result ends up being a positive, and therefore this problem is not possible. So we would just simply say no solution. No solution. And I could actually do it like with this. That's an acceptable way of showing no solutions too, or writing it out. All right, now let's look at when you have binomials on both sides. An interesting kind of little thing. Here, what happens is you essentially still do the same type of thing. Okay, we're still going to apply the same rule. So that means here we're going to do a case A and a case B. In case A, I no longer need the absolute value bars. 8 plus x is equal to 2x plus 3. In the second one, I need 8 plus x is equal to, and we put this into negative. The whole side. Just like if this instead of 2x plus 3, say it was 7, we'd make it negative 7. So 2x plus 3 might be 7 for all we know. We just put a negative in. We don't know what it is, but we just put the negative. So here in this case, I'm going to combine the x's, and I'm going to subtract the 3's, and I get x is equal to 5. And over here, my first thing to do would be to apply that negative correctly. Okay, so it distributes into both. Okay, and then I think I'll add the 2 x's to both sides. So it gives me 8 plus 3x equals negative 3. Go a little bit slower, more steps just to be safe here. Negative 8. So 3x is equal to negative 11. Nothing wrong with that. Looks like we're going to get 2 answers, and one's going to be that one, negative 11 over 3 and 5. So if I divide 3 into 11, I get 10, 9, negative 3.6, like 7 or something. No, unless you're told to do that. You'd have to put the approximation sign, and there's no reason to do that when you can just leave it as a fraction. So I'll leave the exact answer for this. Okay, that was a good thing for everyone to know too. Now let's take a look at this one. Here the absolute value bar is on the right side. So what? That really isn't an effect for you here. That really shouldn't change things on it here. Okay, but now we have a couple of choices. So first one for case A, it's just doing the problem as normal. For case B, I'm going to apply the negative. Now I could do the negative here, or I could do the negative here. It really doesn't matter which one. Okay. I'm tempted to do both, but I'm not sure of time. So I can say negative 3y minus 2 is equal to 6y plus 25. If I were to have applied the negative on the other one, I'd get this. I'd have started off as negative 3y minus 2 is equal to negative 6y plus 25. Well, think about something. This negative here, if I just multiplied both sides by a negative 1, I would get the negative over there. So it really just doesn't matter. It's entirely your choice which way you want to do it, as long as you get the correct answer. So let's work all this out here. All right, so if I add 3y to both sides, I'm going to get a 9y. I'm going to subtract the 25, so I'm going to get negative 27. So that means y is equal to negative 3. And if I put that back in here, I get negative 3 minus 2. That's 9 minus 2 is 11. Here, the absolute value is that's negative 18 plus 25. That's 11. Oh, it's 9 minus 2. Oops, that's positive 9. So that's actually a 7. Negative 18 plus 25 is also a 7. So, whoops, we do that. That means we're correct on this one. So this is the correct answer. Oh, that don't go right. And I really don't mean for it to go away. Let's see. Oh, that looks like that's not going to work. So I'm just going to put the yellow around it. Now let's take a look at this other side. So I'm going to keep it the way I started it there, and I'm going to now multiply that in there. So I'm going to get a positive 3y and a positive 2, and I'm going to get 6y plus 25. Okay. So I'm going to now, let's subtract the 3y's. So I get 3y here, and I'll subtract 25, which actually gives me 23. Ooh, so y is equal to a negative 3, what was it, negative 23 over 3. 25 plus 2, yep, okay. Something's not coming out working for me. Why am I? No, it's coming out, right? That's y plus 25. So we end up with a fraction in this case. You can put the fraction into it. Yep, it would work. If I put this fraction in to here and to here, the good thing is that with 3 on the bottom, this 3 would cancel it out. That 6, that 3 would partly cancel it out. I don't really have the room here to show all of that, but you can do that yourself if you want to check it and see that the negative 23 over 3 is actually going to work. So my answers on this, let me do yellow around here. So my two answers for this is that y is equal to negative 23 over 3 and negative 3. Now let's see if I can get all that in. All right, this works perfectly well. There, so these are some of the variations on the absolute value ones, and you will see that sometimes, the binomials on both sides. Most common, though, is when you see it on one side, and you have to remember the two things that I focused on here, and that is don't make these errors. Remember that there are two cases, and that you have to clean it up. All right, so these first two examples are the key ideas here, and then practice for it. All right, I hope that helps. Thank you for watching and listening.